I have divided my presentation into the 3 topics, and my topic is basically the new guideline that CCPS have come up with on the facility siting. This book or the guideline, which we called as a project number 246, it has published in 2017. This is the 2nd edition. In my presentation, what I tried to do, I'm trying to highlight the key major changes that has been incorporated in this new guideline. And I'm pre-assuming here you are aware about the first guideline, which was released in 2003 on facility siting. Second part of my presentation is how to conduct these studies, but I'm not going into the details of it. I have picked up very few topics, and the major focus is on various evaluation criteria we apply for carrying out facility siting studies. And I'm giving some typical examples. These are not applicable criteria. There are different criteria. You can add up many different. But I'm going to touch upon that area. And the third area is there are a lot of myths and misinterpretation and legends around facility siting studies. I have focused, again because of the time constraint, I have focused when you conduct the building analysis, or when you focus on the explosion analysis and its response on the building, there are many myths and misinterpretation. I'm going to clarify those few legends. So let me get into the presentation itself. So the first part is what are the key changes. As I already told you, it is the 2nd edition, and mainly in this edition what we have done is we have incorporated the good practices that various member companies have adopted since 2003 till 2017. Okay. Because facility siting was very new studies when they started in 2003, a lot of progress has been done, and many companies have good practices around how to survey and select the new sites, how companies are evaluating the acquisitions with respect to the facility siting, how the companies are expanding their existing facilities. So all these good practices we try to incorporate into the new guideline. I'm sorry. Also, if you know that, if you recollect, in 2007, API have come out with a recommended practice around the facility siting. So we incorporated that also in our guideline. API itself have undergone a 2nd revision in just 2 years, because there were too many technological advances were happening. So they have a 2nd edition. So we also incorporated those changes in these new guidelines. As I told you, mainly it was driven with lot of technological advancements that has happened in the field of dispersion modeling, consequence analysis, prediction of the blast damage to the building. Particularly after the 9/11, there was a lot of study around the building damage analysis. A lot of new guidelines have come out. So we have also looked into those guidelines. Also the determination of the occupant vulnerabilities, a lot of studies has been done. So those all technological advancements we try to incorporate in the new book. Also in this book we are talking more about the facility siting study or the selection of the plant site within the community. So that part is also addressed, which was not which was addressed in in the 1st edition, but it was very subtle. Also there are discussions on how to address the long-term risk associated with the life cycle of the plant or the facility. In addition to that, there are 7 appendix. 4 are the checklist around various studies that you are conducting. Appendix B is very interesting, which is basically the separation distances that many of us we are using. OISD also have the separation distances mentioned. and there are many references from regulators, insurance companies and industries. These are available as an appendix in the book. Also, this book incorporates the facility siting related case studies. There are 15 case studies. In the original book there was 4. So, since 2003 to 2016, whatever major case studies were there, we try to incorporate into this. These are the key highlights that are incorporated. Okay. The second part is how we can approach towards the facility siting studies. So, if you look at the approach itself, it is the balance between the selection of your layout. Your day-to-day operations require certain distances to be covered. So, as you carry out the facility siting study, you are either reducing or increasing the distances, but that also has to be balanced against your operational aspects. For example, how much time it will take for an operator to go from the control room to the field. So, it's really a balance between a lot of things. So, the new approach, this approach is, I will say, more a balanced approach that we have taken, and it try to address 3 things. If you look at the outer ring, which is the terrain itself, the middle part is the facility boundary, then the process unit, then the chemical layout. So, it starts from the boundary or the terrain, then gets into the location of your site, then gets into the process units, then gets into the equipment layouts or the equipment layouts. The key part of, or the heart of that is the hazards that you are going to identify. It has also, this is another way of representation of our onion diagram, and if you look at the barrier number 1, 3, 1, 7 and 10, those are basically, those are considered as a barrier. Equipment separation distance, definitely it helps to keep the hazards apart from each other. So, that is one barrier. The second is the process unit separation distances and the facility location. This is the new concept that has been introduced, or I will say this is the concept that has been proposed in the book. When we talk about the analysis method of the facility siting itself, there are various different analysis methods available. Explosion analysis, you can do consequence based also, and you can do the risk based also. And I am going to touch upon only the consequence based. It's the huge concept in itself. But how you apply that facility siting study in the when you are carrying out the consequence base as your basis. You will notice that fire analysis have the third dimension or the third study, which is the spacing table, which is basically based on the fire hazard scenarios. And we all know that consequence based analysis, we do not consider the event of the frequency. It is mainly around the identification of your MCEs, that is maximum credible scenarios, the events, and then you take it forward, and you can do consequence analysis at various levels. You can do a very simplistic analysis where you use simple model like multi-energy blast, curves, building level structural analysis. You can do intermediate kind of analysis where you use the Gaussian dispersion models, multi-energy models, then the component level building damage. So, in simplistic analysis you are just doing the building level structural analysis, but if you go into the intermediate you go more into the component level of the building level analysis. If you go further into the depth of or the further complicated studies or the detailed studies, then you use your CFD models and CFD explosion models, finite element analysis for the building damages and all. So, these are the few studies that you do, or that is how you analyze it. Scenario selection is pretty simple, it's business as usual, most of us know about it. Leak size determination is another thing that is very important or critical. So, you really have to decide how you are going to, or what will be the leak size for your scenarios, and there are different level of suggestions or recommendations given. It starts with you consider that the entire inventory within the unit will get out of the equipment, and then you do your analysis around that. It's also the most famous is, I think, the Dow Chemical Exposure Index criteria, where the line, depending on the line size, the leak or the hole sizes are decided. So there are probabilistic assessments also. So these are few leak size determination methods available. Most important thing is the acceptance criteria. I think when you are carrying out the facility siting study, you really have to decide what criteria you are going to have. There is no one criteria that has been recommended. There are many criteria available, but company have to decide which criteria they are going to apply. I have shown few examples. This is the example of the acceptance criteria for the explosion hazard evaluation, where it is based on the occupant vulnerability. That means if the building get damaged and there are 5 levels of those damages, what will be the fatality, how much percentage of the people there within the building will die. So you need to identify that. And that is again based, I told you this is based on the anti-terrorism design studies carried out by US government. Also the Baker risk, they have provided these guidelines or presented this guideline in 34 annual loss prevention conference. I think this is one important part that we need to understand. When we do the building damage evaluation, this is more like a dynamic analysis of the load. It is not the static analysis. So what is happening here is, this is the simplistic way of representing it. It is called as a single degree of freedom system, where when the explosion waves hit the wall, how it reacts, that's the calculation you have to do, because that's where you will understand how your building component is reacting to the blast pressure. And this is converted into, in a simplistic way, this is converted into, the study is converted into PI diagrams, pressure impulse diagram, what you see here. And these are the diagrams at various pressures and impulses. And what you get here is this zone. These are the 4 zones. The zone which is on the left hand side, if you draw the PI diagram for one component, you will get some numbers, and if you put that number and if that falls on in the zone which is shown on the extreme left hand side, that means there is a low damage to the component. Okay? So that you need to understand. So how you are going to convert your knowledge of your studies that you have carried out for explosion, that you need to convert into the building damage assessment. Based on the building damage assessment, then you can add up the vulnerability criteria, and then you can understand how many people are going to get affected because of that. Okay? I will go further. Fire hazard evaluation. Actually, some are recommending 3-stage criteria. The first stage is you have the contours, fire contours for 1.6 kilowatts per meter square. Then direct flame impingement is there. Then you have to treat them separately, and also you have to calculate the radiation flux, and the certain figures, certain studies has been done. 920 seconds per kilowatt meter square is the criteria that has been recommended. So these are the various criteria. What you need to do is, when you select your studies, you have to adapt some criteria and consistently use that criteria throughout your studies. Spacing table I will just skip. There are certain issues you need to be considered when you are carrying out these studies. These are important issues, and few issues. For example, what if your maximum credible event, it differs between 2 similar sites, and it may happen because 2 different groups are conducting the studies. There are certain issues. Some may use the consequence based method, some may use the risk based method. So you will have different results, how you are going to interpret those results. So when you are carrying out your facility studies, these are the few things that you need to remember. I will go into the myths and legends, and this is more around the explosion consequence analysis. The first is blast proof buildings, and you will agree to this. We do not need to be concerned about our building, it was designed for a blast. That's the statement you will, this is a very common statement you will heard from if you sit for a study. The second is, bigger is the better. That structural member was sized for the blast loading. I can increase its size and add the safety of design. That's one of the legion. Many people are using this. That's not true. You have to understand the design and performance of the component. I told you the way you calculate the diagram I shown you. Blast wall and the shield wall, this is the most interesting, and you will see many people, when you have identified the explosion site, potential explosion site, they put the either shield walls or the blast walls. But you need to understand that blast wave is the region of rapid propagation, and what happens to that shield wall is, you can see. So ultimately what you see here in the red, even though there is a shield wall, you have some impact, blast wave impact on your main structure. So what happens is the blast wave reform itself, it goes around the obstacle, and then it may go and damage your main component. Also roof and side walls you have to remember. Last two more, one myth is I bought 8 PSI portable building, so I am safe. Usually 8 PSI portable building is the terminology that vendor is talking about, but you undergo many changes, there are weaknesses, okay. You need to understand the building level damages. Another legend is overpressure resulting in 1 PSI or less will not cause damage. Many of us have that kind of understanding, but have you considered what happens to the window? Load bearing unreinforced masonry work, they get damaged. I will show you the next figure. This is what has happened actually in T2. It got damaged. The adjacent building got damaged. Okay. Replace the window with laminated gas to make them blast proof. That's another legend. No, that's not true. You really need to understand how the projectile motions of the window when it fails, how it happens, and who is going to get affected because of that. So you need to understand that. The last one, the credible scenarios is overly conservative scenario, and it will never really happen. No, that's not the case. There are black swans, and you need to be aware of those. So use your explosion hazard consequence analysis knowledge well. These are the few references. I'm sorry I have taken 2 more minutes. Thank you so much.